Welcome to the Deep Dive. You're here today for a pretty focused session. We're aiming to get you really prepped for that Lean Six Sigma Master Black Belt certification exam, the one from the Management and Strategy Institute.
That's right. Think of this as really drilling down, not just skimming.
Yeah, we want to pull out the absolute core stuff you need to know to feel confident going into that exam.
Exactly. And we've gone through quite a bit of material, the training modules covering everything from 5S, FMEA, Poka-yoke, DOE,
Hoshinkanori, root cause analysis.
project management, leadership, the Lean Six Sigma fundamentals naturally, pull systems, SBC, theory of constraints, the whole lot.
So a broad sweep. Our goal today is really just to lock down those key ideas for exam success.
Precisely. Pinpoint what's most critical.
Okay, let's dive in then, starting right at the beginning, Lean Six Sigma itself. For someone gearing up for this Master Black Belt exam, what's the absolute must-know definition?
Right. So at its core, Lean Six Sigma is fundamentally a management methodology. It's very data-driven.
Data-driven, okay.
Yeah, and it's sharply focused on getting measurable business results. Improvements you can actually see, and critically eliminating defects.
Got it. And you mentioned it's important to know what Six Sigma isn't. That sounds like classic exam territory.
It really is. You need to be clear. Six Sigma isn't like a standard you just meet. It's not just the certification itself, although that's what you're aiming for.
Right.
And it's definitely more than just a single metric. It's a whole approach, a way of thinking about improving processes.
That's a really helpful clarification. So it's a methodology. Now, what about the lean part? How does that fit in? We hear that term everywhere.
Lean thinking, well, its origins are famously in the Toyota Production System, TPS, developed after World War II.
Ah, TPS, foundational stuff.
Absolutely. And the core ideas of Lean are all about, well, continuous improvement and maximizing value from the customer's perspective. Always the customer first.
Okay.
While at the same time, you're aggressively minimizing waste. Every kind of waste.
Makes sense. So, Toyota Production System TPS. What are the sort of foundational bits of TPS someone needs to really grasp for this exam?
Okay, so TPS is built on 5 key steps. You'll want to know these. First, define value. But crucially, define it from the customer's viewpoint.
Always the customer. Got it.
Second, identify the value stream. Map out everything that happens to deliver that product or service. Find the non-value added steps.
Okay, map it out.
Third, study the flow. You want that product or service moving smoothly without interruptions. Eliminate the blockages.
There's the flow, right.
Fourth, establish pull. This means you only produce when there's an actual customer order, a just-in-time idea.
Pull, not push.
Exactly. And the fifth step, which is ongoing, is strive for perfection, continuous improvement, never stop getting better.
Those 5 steps sound interconnected. Define value, map the stream, ensure flow, use pull, and aim for perfection.
That's the essence of it. Understanding that flow is key for the exam.
I've seen that visual, the TPS house. What's the significance of that metaphor?
Yeah.
How does it help us understand?
Ugh. The TPS house. It's a great visual.
Sure.
Yeah. It's like the blueprint for a lean organization. The roof represents the ultimate goals. Best quality, lowest cost, shortest lead time.
The coals on top. Okay.
And holding up that roof are 2 pillars. Just in time, or JIT, getting what's needed when it's needed, right quantity. And the other pillar is Jidoka.
Jidoka. What's that encapsulate?
It's often translated as automation with a human touch, or maybe more broadly, building quality into the process. Stop and fix problems immediately.
Built-in quality. Makes sense. Pillars supporting the roof. What's the foundation?
People, right at the center. The foundation is the engaged workforce driving and sustaining it all. For the exam, remember the house analogy. Roof, pillars, foundation, people are essential.
Great visualization.
Okay.
Well, let's talk waste. That's central to lean, right?
Yeah.
What are the key categories we need to nail down for the certification?
Absolutely central. TPS identifies 3 sort of big categories of waste. There's MURI, which is overburden, pushing people or machines too hard.
URI overburden.
Yeah. Then there's MURA, which is inconsistency. Unevenness in the workflow, fluctuations, causes lots of problems.
URI inconsistency. Got it.
And the one most people know is MUDA, which is just waste. The non-value added stuff.
And MUDA itself has specific types, doesn't it? Those famous 7 wastes. Crucial for the exam, I imagine.
Oh, definitely. You need to know the 7 types of MUDA. Let's list them. Unnecessary motions.
Like walking around too much.
Exactly. Waiting, any kind of delay. Unnecessary transportation, moving things without adding value. Overproduction, making too much, too soon.
That ties into the push idea we mentioned.
It does. Then there's overprocessing, doing more work than the customer requires. Excess inventories, hiding problems, tying up capital. And finally, defects. Rework, scrap, anything not right the first time.
7 wastes. Got it. I heard there are new wastes, too.
Yeah, it's worth being aware of those. Things like untapped human potential or wasted creativity, not using people's skills fully. While not in the original 7, they're definitely recognized now as significant organizational waste.
Makes sense. Wasting talent is definitely waste. Now, Kaizen, continuous improvement. How does that fit into this philosophy for a Lean Six Sigma practitioner?
Kaizen is the engine, really. It's a mindset of making small, incremental improvements all the time.
Small steps.
Exactly. For the exam, remember the basics. Constantly question how things are done now. Don't just accept the status quo.
Challenge everything.
And importantly, seek advice from the people doing the work before making changes. Get their input. It's about incremental improvements, not huge disruptive changes overnight, usually.
Got it. Small improvements driven by the front line. Now, what if customer demand isn't steady? How does Lean handle fluctuations?
That's where demand leveling and production leveling come in. Haijunka in Japanese.
Haijunka, okay.
These are strategies to smooth out those peaks and valleys in demand. Aim for a more stable, predictable production flow. It helps manage capacity and resources much better in a lean setup.
Smoothing things out. Okay. We also saw Womack's 5 principles of Lean. Is that another key framework for the certification?
Definitely. Womack's principles are a really concise way to think about lean implementation. You should know these 5. First, define value again, customer's view.
Right.
Second, identify the value stream, map it, find the waste. Third, ensure flow, make it smooth.
See the pattern here?
Exactly. Fourth, establish pull, let demand drive production. And fifth, pursue perfection, continuous improvement again. They really reinforce the TPS ideas, just framed slightly differently.
Value stream, flow, pull, perfection.
Got it.
And the Kano model. That sounded interesting for understanding customers.
The Kano model is super useful for understanding customer satisfaction. It breaks down product or service features into 3 types.
Okay.
Must be attributes, things customers just expect. If they're missing, people aren't happy, like brakes on a car.
Basic expectations.
Then, performance attributes. The better these are, the happier the customer, like fuel efficiency. More is better.
Linear relationship.
And finally, surprise and delight factors. Unexpected things that wow the customer, like a free upgrade. Their absence doesn't cause dissatisfaction, but their presence really boosts it. Understanding these helps prioritize improvements based on customer impact.
Must be performance delight. Great framework. Okay, shifting slightly. Variation in complexity in Six Sigma. What are the exam takeaways here?
Okay, variation. In Six Sigma, this is any deviation from what you expect or want in a process. Understanding variation is fundamental.
Right.
And a key related concept is tampering. That's when you adjust a stable process because you're reacting to normal, random variation. It usually makes things worse, increases instability.
It'll fiddle unnecessarily.
Exactly. You need to distinguish that from reacting to a real signal, special cause. We also mentioned structural variation, more predictable, systemic shifts. Knowing the type of variation guides your action.
And complexity. How does Six Sigma view that?
Complexity, in Six Sigma terms, is often about non-value-added processes that are also high cost. The key idea is that unnecessary complexity itself is a huge source of waste and cost.
Makes sense.
So optimization and standardization are the main ways to simplify things. Cut out the unnecessary steps, make it leaner, cleaner.
Reduce variation, simplify complexity. Seems like core goals. Now, the improvement frameworks,
Right.
PDSA and DMAIC, crucial for the exam, I assume.
Absolutely fundamental. You have to know these. PDSA is plan, do, study, act. It's an iterative cycle for testing changes.
Plan, do, study, act, the iterative cycle.
Right. You plan a change, try it out, do, analyze the results, study, and then act based on what you learned. Repeat. Great for continuous refinement.
And DMAIC, that's the big one for Six Sigma projects, right?
Yeah.
What do we need to remember for the certification?
Yes, DMAIC is the structured, data-driven heart of Six Sigma problem solving. Define, measure, analyze, improve, control.
Define the problem scope, team.
Exactly. Measure, collect reliable data on the current state. Validate the problem exists with numbers.
Measure the baseline.
Analyze. Dig into the data, use the tools, find the root causes. Why is this happening?
Analyze for root cause.
Improve. Develop, test, and implement solutions that target those root causes.
Fix it.
And control. This is key. Put things in place to make sure the improvements stick. prevent backsliding. Knowing the purpose and key activities of each phase, define, measure, analyze, improve, control is critical for the exam.
DMAIC. Define, measure, analyze, improve, control. Got the flow. Okay, one last thing in this section. GEMBA. What's the takeaway there?
Gemba, Japanese term meaning the actual place, where the work happens, where value is created.
I will see for yourself.
Precisely. The 5 rules of Gemba emphasize going to the source. Observe directly. Talk to the people involved. Don't rely on reports alone. You need that first-hand understanding for real problem solving.
Go to the GEMBA. Makes sense. Okay, moving to key topic 2, pull systems and just-in-time. Feels like a direct follow-on from lean principles. What's the core idea for the exam?
It absolutely is. The core idea of pull is minimizing waste by only producing what's needed when it's needed. Production is triggered by actual demand, not forecasts.
Demand triggers it.
Exactly. And for the certification, you need to understand the contrast. Push versus pull. Push systems make stuff based on forecasts, often leading to excess inventory. Pull systems react to demand.
And the advantages of pull.
Faster response, easier control, less effort, less space needed, lower costs, generally much more efficient if you can manage it.
So that customer demand signal really drives everything upstream. How does that work in practice?
Yeah, when a customer takes or uses something, it sends a signal back up the chain, replenish this, which triggers the step before it, and so on, like a cascade of instructions flowing backward based on real consumption.
Cascading signals, okay?
Nothing gets made just in case it might be needed.
I remember hearing inventory can hide problems, like water covering rocks. Why is that key for understanding pull systems?
That's a great analogy. Lots of inventory can mask underlying issues, unreliable suppliers, bottlenecks, quality problems. You don't notice them as much.
Because you have buffer stock.
Right. But when you implement a pull system and deliberately lower inventory levels, those rocks get exposed. It forces you to fix the underlying problems.
Forces improvement.
Exactly. You have to reduce variability, cut waste, streamline flow, improve information accuracy. Lowering inventory becomes a driver for improvement.
You can't fix what you can't see. Makes perfect sense. Now, just in time, JIT, seems very close to pull. How should we differentiate them for the exam?
They're very closely related. JIT is maybe a broader management philosophy. It's about continuous problem solving by driving out all waste, with a real focus on minimizing inventory.
Broader philosophy.
Yeah, the goal of JIT is the right materials, right place, right time, exact quantity needed. Minimize warehousing, minimize tied-up capital. Pull systems are a key tool or mechanism to achieve JIT.
So pull is a way to implement the JIT philosophy. What are the core JIT principles for the test?
2 big ones to remember. Establish time. That's the rhythm of customer demand, setting the pace for production.
Tact time, the customer heartbeat.
And second, build pull product using a Kanban system.
Kanban, the signaling system, right? The visual cards or bins?
Exactly. Kanban is that visual signal could be a card, a light, an empty container that tells an upstream process, hey, we need more. It authorizes production based on actual downstream consumption.
It's the pull signal.
Right. And for the exam, understand that the number of Kanbans in the system controls the work in process inventory. There are calculations for Kanban quantities based on lead time, demand rate, etc.
Now, quality seemed really important for JIT. Why is high quality so critical there?
Because in a JIT system with minimal inventory buffers, a quality problem stops everything. If you make a bad part, there's no pile of good ones to grab instead. Production can grind to a halt.
Big impact.
Huge. So JIT demands quality at the source. Every worker is responsible for checking their own work and never passing a defect downstream. It contains problems immediately.
Never pass along defects. Powerful. We also heard about one-piece flow and continuous flow. Are these realistic goals or just ideals?
They're often seen as the ideal, the ultimate goal to strive for. One-piece flow is moving just one unit at a time through the process. Continuous flow is the dream of no waiting, no interruptions between steps.
The perfect flow.
Right. While perfect one-piece continuous flow is hard to achieve everywhere, aiming for it helps you constantly identify and remove waste and bottlenecks. It's a benchmark.
Something to aim for. What about standardized work? How does that support JIT and pull?
Standardized work is critical. It's the documented, best-known way to do a task right now. It includes takt time, the standard work-in-process inventory for that task, and the specific sequence of steps.
Documenting the best way.
Exactly. It ensures consistency, reduces variability, locks in best practices, and gives you a stable baseline to improve from. Essential for making JIT and pull reliable.
And production smoothing or leveling, Hajunka. How does that help pull systems?
Hajunka, or production smoothing, aims to balance both the volume and the mix of products over time, instead of big batches of one thing then another.
Like Toyota making different car models throughout the day.
Precisely. That example shows how leveling production better matches the actual mix of customer demand, reduces overall inventory, and creates a more stable workload. It makes the pull signal from the customer smoother and easier for the system to handle.
Okay, that covers pull and JIT well. Let's shift gears to key topic 3, statistical process control, SPC. This feels like where the Six Sigma statistical side really shines. What's the core idea for the certification?
You're right, this is deep in the Six Sigma toolkit. SPC uses statistical methods to monitor a process over time. The goal is to see if it's stable and predictable, and crucially, to spot when unusual things are happening, special causes of variation.
Stable and predictable. Spotting trouble.
Yeah. It's vital for the control phase of DMAC. Remember for the exam, all processes vary naturally. SPC helps us tell the difference between that normal expected noise and a real signal that something specific has changed and needs fixing.
Distinguishing normal noise from real signals. There were different control charts, right? Which ones are key for the Master Black Belt exam?
Yes, different charts for different data types. You've got charts for attribute data, like counts or proportions of defects.
Attribute data charts.
Key ones are U charts for defects per unit when sample size varies, NP charts for number defective with constant size, P charts for proportion defective, and C charts for number of defects with constant size.
Okay, U, NP, P, C for attributes. What about variable data? Measurements.
For variable data measurements like length or weight, the most common are X-bar R charts, tracking the average X-bar and range of small subgroups. Also, X-bar S charts for larger subgroups using standard deviation, S, and XR charts for individual measurements and moving range.
X-bar S, X-bar for variables, any others?
You might see EWMA charts, exponentially weighted moving average. They're good for detecting small, gradual shifts in variable data. Knowing which chart to use for which data type is definitely exam territory.
Okay, match the chart to the data. Now, interpreting them. There are rules for spotting an out-of-control process, aren't there? What should we memorize?
Absolutely. Correct interpretation is key. There are standard rules, often called the Western Electric Rules, or similar sets. Things like a single point outside the control limits, usually plus minus 3 sigma.
Obvious one.
Right, or say 2 out of 3 consecutive points beyond the 2 sigma warning limits on the same side, or a run of 8 or more points all above or all below the center line.
Runs and trends.
Exactly. Trends of 6 or more points going steadily up or down. Alternating patterns, like 14 points going up and down. Any clear, non-random pattern suggests a special cause is acting on the process. You need to know these rules.
Sounds like flashcard time for those rules. What about collecting the data for SPC? Key considerations.
Garbage in, garbage out applies here. You need good data. Define clearly. What characteristic are you measuring? What's your sample size each time? How often will you sample frequency? Where exactly is the data coming from? Source. Consistency is vital.
Clear definitions, consistent collection. Got it. Can you quickly recap the main use case for those specific charts like X-bar, U, P, etc.? Just a quick reminder for exam prep.
Sure. X-bar monitors process average and spread using small subgroups. Good for detecting shifts and changes in variability. U-chart tracks defects per unit when the sample size isn't constant. P-chart tracks the proportion defective. NP-chart tracks the number defective but needs constant sample size. EWMA, sensitive to small, sustained shifts in the average for variable data.
Okay, each has its niche. Now, what's a control plan in SPC?
A control plan is basically the instruction manual for keeping a process in control using SPC. It documents everything. The critical characteristics, CTQs, being monitored, which control chart to use for each, where to collect data, how to measure it, how often to sample, and crucially, what to do if the chart signals an out-of-control state.
The reaction plan. Important.
Very. It's the blue point for sustained control.
We also talked about random versus systematic variation. The difference seems fundamental.
It is. Random variation is the inherent natural noise in a stable process. Lots of tiny, unavoidable causes. Systematic variation, or special cause variation, comes from specific, identifiable factors outside the normal process.
Like machine breaking or a new operator.
Exactly. Recognizing the difference is critical because the response is different. You accept random variation if it's within acceptable limits, but you investigate and eliminate systematic variation. Techniques like hypothesis testing often come in here to pinpoint those special causes.
Okay. And sampling strategies for SPC data. What were the main ones?
4 main strategies mentioned: consecutive sampling, taking samples back to back; random sampling, everyone has an equal chance; stratified sampling, dividing into groups first, then sampling from each; and rational subgrouping. This is key for SBC. You select samples so variation within a subgroup is small, capturing common cause, while variation between subgroups highlights special causes.
Rational subgrouping sounds important for chart sensitivity. Lastly, centerline and control limit calculations. What's the gist for the exam?
The centerline is usually the process average calculated from your sample data. Control limits are typically set at plus and minus 3 standard deviations from that centerline. They define the expected range of random variation.
Plus minus 3 sigma.
Right. Points outside suggest a special cause. The calculations involve basic stats, mean, standard deviation. And remember, nowadays, automated SBC systems often do this in real time in manufacturing.
Okay, solid grounding in SPC. Let's pivot to key topic 4. FMEA, Poka-yoke, and DOE. This feels more proactive about preventing problems.
Exactly. FMEA, failure modes and effects analysis, is all about being proactive. It's a systematic way to look at a process and ask what could go wrong, what would the effect be, what could cause it, before it happens.
Anticipating failure.
Yes. And for the exam, remember tools like Pareto charts help prioritize which potential failures have the highest risk based on severity, occurrence, detection. And the 5 whys technique helps drill down to the root cause of those potential failures.
So FMEA finds potential problems. What then? How do we prevent them?
That's where Poka-yoke comes in. Mistake proofing is any mechanism or procedure designed to prevent an error from happening, or at least make it immediately obvious if it does.
Like a plug that only fits one way.
Perfect example. Could be mechanical, electrical, visual cues, checklists, anything that helps people do it right the first time. There's the shutout approach too, which physically prevents the error.
FMEA anticipates, Poka-yoke prevents. Got it. Now, design experiments, DOE. Sounds more advanced. What's the key idea for the certification?
DOE is a powerful statistical method for systematically figuring out how different input factors affect a process outcome. Instead of changing one thing at a time, you change multiple factors in a structured way.
More efficient than one factor at a time.
Much more. The goal is to identify which factors really matter, find their optimal settings, and understand how they might interact with each other. It's about efficient learning and optimization.
What are the key design principles for a good DOE? Things to remember for the exam.
Several key ones. Power the ability to detect an effect if it's there. Sample size, N, how many runs. Balance testing factor levels evenly. Repetition, replication, repeating runs, or the whole experiment to estimate error. Efficiency, getting max info with minimum runs. Randomization, running trials in random order to avoid bias. And blocking, managing known nuisance factors that aren't your main focus.
Rigorous planning needed. We heard terms like interaction, confounding, resolution. Can you break those down simply?
Sure. Interaction is when the effect of one factor depends on the level of another factor. They work together, basically.
Combined effect.
Confounding is when the effects of 2 or more factors are tangled up in your results. You can't tell which one caused the change. This is common in fractional designs.
Mixed up effects.
And resolution describes how much confounding exists in a fractional factorial design. Higher resolution means less confounding, clearer results, but usually more runs.
Interaction, confounding, resolution. Got it. What's the main objective of doing a DOE?
Simply put, to discover the key factors that control an outcome so you can optimize the process.
We also contrasted full factorial and fractional factorial experiments. What's the difference, and why choose fractional?
Full factorial tests every possible combination of factor levels. Very thorough, gives you all main effects and interactions clearly, but it gets huge fast with many factors.
Impractical sometimes.
Right. Fractional factorial tests only a carefully chosen subset of those combinations. Much more efficient, especially for screening many factors early on to find the vital few. Resolution levels like RT or IV, RV tell you what's confounded. You trade off some clarity for efficiency.
Use fractional to screen. Maybe full factorial later on the important factors. Makes sense. Lastly here, fit, diagnose, model, and center points in DOE. Key concepts.
Fit is about finding the statistical model, often a regression equation that best explains how the factors influence the response. Diagnose model is checking if that model is actually good. Does it fit the data well? Are the assumptions met? This involves looking at residuals, understanding data distributions, normal, binomial, etc.
Checking the math.
Basically, yes. Understanding normal distribution, central limit theorem, maybe chi-square tests for distribution fit that's relevant, and center points are runs done with all factors at their middle levels. They help detect curvature if the relationship isn't just a straight line.
Okay, FMEA, Poka-yoke, DOE, proactive tools covered. Let's move to key topic 5, root cause analysis, RCA. Getting to the bottom of problems that have happened. What's critical here for this certification?
The absolute critical point for the exam is understanding what a root cause is. It's the fundamental factor that, if you fix it, prevents the problem from happening again. RCA is about digging past symptoms to find that fundamental cause.
Not just patching symptoms.
Exactly. You want permanent solutions.
What's the typical structured process for doing RCA effectively?
It generally follows these steps. 1. Clearly define the problem. 2. Contain it, stop the bleeding, then analyze its scope. 3. Investigate to identify the actual root causes. 4. Develop and implement corrective actions targeting those root causes. 5. Validate that the fix worked and the problem is gone for good. The benefit. Saves time, money, stops recurrence.
Sounds logical. The approach seemed important too, the contrast between usual and preferred. What's the mindset difference?
Big difference. The usual approach often defaults to blaming people, which means the underlying system issues don't get fixed and the problem eventually comes back.
The blame game.
Right. The preferred approach, the Lean Six Sigma way, is data-driven. It focuses on the process, not the person. It needs a no-blame culture. Solutions are validated and shared to prevent recurrence anywhere. It's about fixing the system.
That no-blame environment sounds crucial. Why is that psychological safety so important for finding root causes?
Because you need people to speak up honestly. If they fear blame, they won't share crucial information about what really happened or what systemic flaws exist. The truth is, most human errors are triggered or allowed by faulty processes or systems. Blame just hides the real problems.
Fosters learning, not fear. Got it. What are the specific steps in a thorough RCA process? You mentioned 8.
Yeah, a common structured approach has about 8 steps. 1. Form the right team, diverse skills, process knowledge. 2. Define the problem clearly, the 5 W's and 2 H, who, what, where, when, why, how much, many, helps here.
Define the problem sharply.
3. Take immediate containment action and verify it works. 4. Determine the root cause. This is where tools like brainstorming, fishbone diagrams, Pareto charts, and especially the 5 whys come in.
The investigation part.
5. Develop a corrective action plan. Make sure actions are smart, specific, measurable, achievable, relevant, time-bound. Verify the plan before rolling it out. 6. Implement the plan, timeline, communication. 7. Develop a follow-up plan, monitor the results. 8. Validate the fix is permanent and celebrate the team's success.
That's comprehensive. The fishbone diagram or cause-effect diagram is pretty common. What's its main purpose? How do you build one?
Its main purpose is to visually brainstorm and organize all the potential causes contributing to a specific effect or problem. You put the problem at the head of the fish. Then you draw main bones for major categories of causes, often things like methods, materials, machines, manpower, measurement, environment.
The 6 M's sometimes?
Right, or variations. Then you brainstorm specific causes under each category, adding smaller bones for sub-causes. It helps structure thinking and ensures you consider different angles.
Visual brainstorming. And what makes for a good RCA? How do you know if you've really dug deep enough?
A good RCA is, well, internally consistent. The cause logically explains the effect. It's thorough, doesn't stop at the first easy answer. It's credible based on evidence and data, not just opinion. It's often interdisciplinary, brings in different perspectives. And ultimately, it leads to effective actions that truly address the root cause and prevent recurrence.
Consistent, thorough, credible, interdisciplinary, actionable. Got it. Okay, RCA nailed down. Let's shift to strategy with key topic 6. Hoshin or policy deployment. Sounds very high level.
It operates at a high level, yes. Hoshin is essentially strategy deployment. It's a system for translating top management's vision and big breakthrough goals into concrete plans and actions, cascaded down through the entire organization.
Connecting the top floor to the shop floor, strategy-wise.
That's a good way to put it. The aim is that everyone knows the big picture strategy and exactly how their daily work contributes to achieving it. Alignment is key.
Alignment. I remember it operates at two levels.
Yes, Hoshin operates at the strategic planning level, setting those long-term breakthrough goals, and also at the daily management level, maintaining and improving the core processes that support those goals. And importantly, it uses the PDCA cycle at all levels. Plan, Do, Check, Act drives the whole thing.
PDCA again. What does an organization need to have in place before trying Hoshin Kanri? Any prerequisites?
It helps if there's already a clear strategic plan. Also, a culture that's reasonably responsive to the market and ideally a foundation of a high-performance culture. Hoshin is the how of achieving strategy, so having a strategy and a performance focus helps it take root.
So have a plan first. What kinds of behaviors does Hoshin Kanri try to encourage?
It fosters some critical behaviors, seeing work as processes, not just tasks, empowering employees to take ownership, aligning everyone around shared goals, promoting continuous improvement, using quality tools regularly, recognizing how different functions need to work together as a team.
It sounds like it drives a certain culture. The term catchball came up. What's that process?
Catchball is absolutely vital for the alignment part. It's how you break down the big strategic goals. Top management sets the direction they throw the ball down. The next level team develops their specific objectives and plans. In response, they catch the ball and figure out their part.
Then they throw it back up.
Exactly. They throw their plans back up for discussion, feedback, negotiation with the level above. This back and forth continues level by level until everyone has clear, aligned, measurable goals they understand and own. It ensures buy-in and accountability.
Collaborative goal setting. Okay. We also heard about business fundamentals plans versus breakthrough performance plans. What's the difference?
Business fundamentals plans are about maintaining and incrementally improving the core day-to-day business processes. Keep the lights on, run things efficiently. Breakthrough performance plans are focused on achieving major strategic shifts. Where do we need to be radically different in 3-5 years, and what big initiatives will get us there?
Maintain versus transform. Got it. And the planning cycle for those breakthrough plans, key stages for the exam.
Yeah, the cycle typically involves describing the current situation, doing a SWOT analysis, strengths, weaknesses, opportunities, threats, reaffirming the mission, vision, values, strategy, updating the long-range plan, developing the specific annual breakthrough plan with targets, and then evaluating results regularly against that plan, the Check Act part.
How do the annual breakthrough plan and the business fundamentals plan differ in practice? Objectives, scope, measures.
The annual breakthrough plan usually targets a few critical strategic initiatives, maybe involving 10–20% of the organization, often cross-functional teams. Measures are focused on hitting those specific breakthrough targets. The business fundamentals plan covers the broader organization, 80–90%, focuses on maintaining current performance, usually deployed through the normal management structure. Measures are more operational efficiency, cost, daily quality metrics.
Different focus, different scope, different measures. Okay, Hoshin Kanri strategy alignment covered. Let's move to key topic 7, Lean Six Sigma project management. Applying all this within a project structure.
Right. So first, what's a project? A temporary effort to create something unique, product, service, result. It has a start and end date, specific goals.
Temporary, unique outcome.
And project management is applying all the knowledge, skills, tools, and techniques to make that project meet its requirements.
What makes a Lean Six Sigma project successful? What are the hallmarks?
Successful ones typically have really clear, measurable goals tied to business objectives, clear ownership, a realistic timeline, a dedicated team, a defined methodology like DMAE, controlled execution, proper evaluation of results, and crucial, management support.
Management support is key. What about the project manager role in these projects? Key skills.
The PM plans, executes, closes the project, needs strong leadership, negotiation skills, great communication, time management, problem solving. They need to be adept with the project management tools and methodologies themselves. They orchestrate the whole thing.
The orchestrator.
Yeah.
We heard about the PMBOK project management body of knowledge. How does that framework fit with Lean Six Sigma projects?
PMBOK provides a broad set of project management best practices. It talks about 5 process groups: initiating, planning, executing, monitoring and controlling, closing, and 10 knowledge areas like scope, time, cost, quality, risk, etc. While Lean Six Sigma projects often use DMAIC as their core improvement methodology, the PMBOK framework is really useful for managing the overall project structure. Things like stakeholder management, detailed risk planning, communication plans, they complement each other.
So DMAIC for the problem solving, PMBOK for the overall management structure, and the triple constraint: Scope, schedule, budget, still relevant.
Always relevant: scope, time, schedule, cost, budget. They're interlinked. Change one, and at least one of the others will likely be affected. If project scope creeps up, you'll probably need more time or money or both. Managing these trade-offs is a constant balancing act for the PM.
The balancing act. Let's walk through the phases. Initiation first. What happens at the very start of a Lean Six Sigma project?
Initiation is about getting the project formally authorized and defined at a high level. You identify stakeholders, understand their needs, define the problem or opportunity clearly, set those SMART goals linked to the business, outline the initial scope, deliverables, success criteria.
Laying the groundwork. What documents come out of initiation?
Key ones include the Statement of Work, SOW, what work will be done. Project requirements, document what the outcome needs to achieve, maybe a project planning worksheet. And crucially, the project charter. This formally authorizes the project and gives the PM authority.
The charter gives the green light. Okay, after initiation is planning. What needs to go into a solid plan for a Lean Six Sigma project?
Planning is where you build the detailed roadmap, manage expectations, create the work breakdown structure, WBS, breaking the project into smaller tasks, develop the schedule, who does what, when, milestones, figure out resources, develop the risk management plan, what could go wrong, how we'll handle it, and create the communication plan, who needs to know what, when.
The work breakdown structure, WBS, sounds fundamental.
It really is. It's that hierarchical breakdown of all the work, makes it manageable, easier to estimate time and cost, assign work, track progress. You break down the big deliverables into smaller work packages.
And the risk management plan, anticipating trouble.
Exactly. Identify potential risks, assess their probability and impact, plan your responses. Can we mitigate it? Reduce likelihood impact, avoid it altogether, transfer the risk, like insurance, or just accept it and have a contingency plan. Being prepared is key.
Okay, planning done. Then execution. What's important here?
Execution is doing the work defined in the plan. A key thing here is that the plan should have established baselines for scope, cost, and schedule. These are your benchmarks. You'll track actual performance against these baselines.
Baselines for tracking. How do PMs track progress? That's monitoring and controlling, right?
Yes, monitoring and controlling happens alongside execution. How do you track? Regular status meetings and reports, direct observation, analyzing data comparing actuals to baselines, cost variance, schedule variance, using visual tools like Gantt charts to see progress against milestones.
Keeping an eye on things. What if the project runs into trouble? Those triple constraint reduction methods.
Right, if you're falling behind schedule or going over budget, you might need to take action. Crashing. Add more resources to speed things up, often costs more. Fast tracking. Do tasks in parallel that were planned sequentially can increase risk. De-scoping. Reduce the project scope to meet the original time budget. Stakeholders must agree.
Crashing, fast-tracking, de-scoping. Options to get back on track. And managing changes needs a formal process.
Absolutely critical. You need a formal change management process. Someone requests a change, it gets documented, its impact on scope, time, cost is assessed, key stakeholders approve or reject it, and if approved, it's communicated and the plan baselines are updated. Uncontrolled change is chaos. Risk monitoring also continues throughout managing existing risks, identifying new ones.
Formal change control. Got it. Okay, project management covered. Let's turn to key topic 8. Leadership in Lean Six Sigma. How is leadership different here?
Leadership in this context is really about more than just managing tasks. It's about creating a vision for continuous improvement and really energizing people to pursue it.
Vision and energy.
Yeah. Key aspects include communication, constantly reinforcing the vision. Charisma helps inspire people. Competence leaders need to understand the principles themselves, energizing people motivation, and having that clear vision of the future state.
How does a leader create an environment where people are actually passionate about this stuff?
You need the right conditions. A clear mission and purpose helps people connect. Suitable rewards and recognition, not just money, but acknowledging effort and success. Building trust and psychological safety. People need to feel safe trying things and speaking up. And crucially, leading by example. Leaders have to walk the talk.
Leading by example always comes up. How about developing that vision and setting goals? Any techniques?
One interesting technique is looking back from the future. Imagine you've achieved the goal, say, in 3 years. What does it look like? Then work backward. What steps did we take? What milestones did we hit? It helps clarify the path. And good planning is essential to turn that vision into concrete, actionable goals.
Working backward from success. Interesting. What about the circle of influence? Why is that relevant for leaders here?
Understanding your circle of influence where you can actually make a difference helps you focus your energy effectively. It relates to tactics, your specific actions, strategy, how they fit the big picture, and diplomacy, how you work with others. The art of war principles mentioned, know when to fight, choose battles, seek alternatives, are about applying influence strategically.
Strategic influence. How about motivating the team? Maslow's hierarchy was mentioned. How does that apply?
Maslow's hierarchy, or similar models like a management hierarchy of needs, reminds us that people have different levels of needs. Basic needs like security and fair pay must be met, but higher level needs, recognition, growth, purpose, accomplishment, are powerful motivators, especially for engaging people in improvement efforts. Leaders need to understand and address these different needs.
Address the whole person. Personality types, like Myers-Briggs MBTI, also came up. How does understanding personality help a Lean Six Sigma leader?
MBTI, with its dimensions like extroversion, introversion, sensing, intuition, thinking, feeling, judging, perceiving, gives insights into how people prefer to take in information, make decisions, and interact. Understanding these differences and the broader temperaments, traditionalist, experiencer, conceptualizer, idealist, helps leaders communicate better, tailor their approach, build stronger teams, and leverage diverse thinking styles for problem solving. It's about appreciating different perspectives.
Appreciating diversity in thinking. We also talked about helpful versus unhelpful team behaviors, examples leaders should watch for.
Helpful behaviors to encourage: active listening, gatekeeping, ensuring everyone speaks, summarizing, constructive confrontation, mediating, encouraging, observing team dynamics. Unhelpful ones to curb: labeling people, dominating, shutting others down, naysaying, that'll never work, yes-butting everything. Leaders shape the team's interaction patterns.
Foster the good, manage the bad. Finally here, coaching. What's the role of coaching for a Lean Six Sigma leader?
Coaching here is about guiding team members to develop their own problem-solving and improvement capabilities. It's less about giving answers and more about asking powerful questions that help people think for themselves and find solutions. The OO model, objective, overview, options, outcome, provides a simple structure for these coaching conversations. It builds capability.
Ask, don't tell.
Builds self-sufficiency.
Okay, leadership essentials covered. Last topic, key topic 9. Theory of constraints, TOC. This offers a different lens on system improvement, doesn't it?
It really does. The core idea of TOC is that any system's output is limited by its weakest link, its constraint, or bottleneck. This is usually the slowest operation in the process.
The bottleneck sets the pace for the whole system.
Exactly. The whole system can only go as fast as its bottleneck allows.
So what's the main purpose of applying TOC?
The purpose is to identify that constraint and then manage the entire system around maximizing the output of that constraint. You exploit it, get the absolute most out of it to maximize the throughput of the whole system.
Focus on the bottleneck. The drum buffer rope system was mentioned. Can you explain that?
Drum buffer rope is the mechanism TOC uses to manage flow based on the constraint. The drum is the constraint itself. Its pace sets the beat for the whole system. The buffer is a strategically placed small amount of inventory right before the constraint, ensuring it never starves for work.
Keep the bottleneck busy.
Right. And the ropes are signals, like Kanbans in a way, sent from the constraint back upstream, telling earlier processes when to release new work into the system. It prevents upstream operations from overwhelming the constraint and building up massive WIP.
Synchronizing everything to the drumbeat of the constraint. What are the TOC steps we need to know for the exam, the 5 focusing steps?
Yes, the 5 focusing steps are crucial. 1. Identify the system's constraint. 2. Decide how to exploit the constraint. Get the most out of it with existing resources. 3. Subordinate everything else to that decision. Make sure other processes support the constraint. 4. Elevate the constraint. Invest time, money to increase its capacity. 5. If the constraint moves elsewhere, go back to step 1. Don't let inertia become the new constraint.
Identify, exploit, subordinate, elevate, repeat. Got it.
Uh-huh.
Any pitfalls or issues with implementing TOC?
You have to be careful. Truly exploiting the constraint is key. Subordinating other operations needs care. You don't want to create problems elsewhere unnecessarily. Sometimes non-bottlenecks might seem underutilized, but that might be okay if the constraint is working flat out. Don't rush to cut capacity elsewhere too soon.
It requires careful system thinking. TOC also has a specific take on financial issues, right? Different metrics.
Yes, very distinct. TOC defines the goal of a for-profit company as making more money now and in the future, with satisfying customers' employees as necessary conditions. It uses 3 key operational metrics: throughput, Sales revenue minus truly variable costs, basically raw material costs.
Throughput, okay.
Inventory. All the money tied up in things intended to be sold includes raw materials, WIP, finished goods valued at material cost only, and operating expense, all the money spent to turn inventory into throughput, everything else, labor, overheads, etc.
Throughput, inventory, operating expense, TIOE.
Right. TOC says you improve by increasing throughput and decreasing inventory and operating expense in that order of priority. Profit is simply throughput minus operating expense. It shifts focus away from traditional cost accounting per unit towards maximizing the flow of money through the system via the constraint.
Focus on flow and throughput generation, not just local cost cutting.
Precisely. The essence of TOC is focus, find the constraint, and follow through, apply the 5 steps relentlessly. Manage the constraint, achieve the goal.
Well, that brings us to the end of this pretty intensive deep dive. We've covered a huge amount of ground relevant to the Lean Six Sigma Master Black Belt exam. Thank you for guiding us through all of that.
My pleasure. I really hope this overview helps structure the preparation for everyone listening.
Absolutely. So, to you, our listener, we've hit the major topics: fundamentals, pull systems, SPC, FMEA, DOE, RCA, Hoshinkanri, project management, leadership, and TOC. As you study for the certification, use this as a guide. Think about how these concepts connect.
Right, they aren't isolated topics. They all work together in a real-world improvement context.
Understanding these connections won't just help you pass the exam, it'll make you a much more effective leader and change agent in your work.
That's the real goal, isn't it? Practical mastery, not just the certificate.
Indeed. And on that note, here's a final thought for you to take away. Which of these principles or tools we discussed today resonates most with the challenge you're facing right now? Pick just one. How could you apply it, even in a small way, starting tomorrow? Something to think about. Thanks for joining us for this deep dive.